Hello guys. So in this lecture we'll talk about this is the lecture 2 of the last section, which is object oriented programming or fundamentals of object oriented programming. Okay. So in this lecture we'll talk about two things. The first one is destructor. What is the purpose of destructors? Okay. And what is uh, what are the four pillars of object oriented programming? Okay. I already told you the names of all these four pillars of object-oriented programming. But before getting into destructors, okay, and these pillars of OOPs, let me correct myself. Okay, so in the previous lecture, I said that abstraction is what we call as data hiding, but it was wrong. Okay, so the use of access modifier, okay, the use of access modifier, that we done in the previous video. Okay, access modifiers are like public, private and protected, right? So yeah, so the use of this, okay, to hide the, to make the data members, to manipulate the data members, and making them read only, or uh, to, by making public we can use them anywhere in the program, right? By making private we can make them read only, or protected we can make them read only until unless we use getter and setter function. So yeah, so this comes under encapsulation and not abstraction. Okay, so this you have to keep in mind. This is encapsulation. Okay, binding the data members in the form of capsules. Okay, so this is also called binding data members, or member functions. Okay, member functions, I already told you what are data members and member functions. Okay, so binding data members or member functions in the form of capsules, okay, in form of capsules, okay, is called encapsulation. Okay, encapsulation, they are also used to uh, modify the data, okay, like to make them public, okay, to make them private, so that they can already be accessed by using getter and setter functions. So this comes under encapsulation. So this is also a pillar of object oriented programming. So I already told you about a pillar, okay, which is encapsulation. Now let's see what are destructors, why they're used, and before getting into destructors, we also must know one thing, which is this. Okay, this keyword. Okay, so what is this keyword? Okay, so this keyword implies it is the pointer to the current object. It is the pointer to the current, okay, object. Okay, so what I mean by this, okay, and where the this keyword is used. So let's see. Okay, so we have a class. Let's say the has class name is human, and let's say it has, public data members. Let's say the data members are int age. Let's say it has int weight, and let's say it has another data member int height. Okay, int height. Okay, so this is the human class, and it has three data members. Okay, three data members. Now let's say I try to create a constructor. So I'll have to give the class name similar, okay, in the similar fashion, like h is capital, so I'll have to give the name of constructor. I'll have to give the h capital in the constructor as well. Now let's say this is a parameterized constructor, and let's say I pass the same name of the data member, okay, in the parameters. Okay, int weight. Okay, uh, int height. Okay, this should be t. Int height and int age. Okay, in this case, sorry, in this case, the this keyword can be used to denote these data members, okay, which we have defined as the uh, properties of the object. Okay, so how do we use this keyword? This, okay, we'll write this. and then we will use a arrow operator. So this is arrow operator, and then to represent age we write it this way, this dot a this arrow age, and then we assign it a value age. Okay, so this won't create any confusion now. This arrow age represents this age, and this age represents the value that you are passing in the parameter. Okay, similarly for weight as well, this arrow weight, okay, equals to weight. Okay, so this part, this left part, okay, this represents this weight. Okay, that is the data member, and this weight represents the weight that we have passed in the parameter. And finally this okay, let me change the color, this dash height, this arrow height equals to height. Okay, so here also the left part indicates the height which is the data member, and the right part indicates the height that we have passed in the parameter. So this is the pointer to the current object. Okay, to the current object, and object has a property called height, so this is the pointer to the height property of the current object. Okay, now how do we work with this? Let's get back to the Visual Studio Code and let's see how it works. Okay, so this, I'll call it this.cpp. Okay, let's try to create the class. Okay, okay, so let's write the boilerplate code. Okay, what the okay, yeah, so now let's say I create a class human. Okay, okay, so I give it a data mem, I give an access modifier as public. Now let's say I give it the three data members, int age, int weight, which are going to be the properties, right? Int height. Okay, so a human has a height, weight, and age, right? Now if I want to create a constructor, if I create a constructor, sorry, if I create a constructor, okay, I'll have to give the same class name. Now let's say we create a parameterized constructor where we pass value of weight, height, and age, which we want to assign to this particular object. Okay, okay, and age also. Okay, okay, okay. So now to point to this data member, to assign this value to the age data member, we'll write this. Okay, since the data member and the parameter has the same name, so to denote this data member will give this will use this keyword. Okay, this arrow age equals to age. Okay, so the left part here, okay, this represents the data member, and this age represents the parameter, this right part. Okay, and thus the value is assigned to the data member age. Okay, similarly we can use this keyword for the other two data members as well. Weight, okay, equals to weight. Okay, and this dash, okay, this arrow height equals to height. Okay, this way we can use the constructor. Now let's try to use this let's try to create the object. Okay, so to create the object, we'll write the class name human h. Let's say h is the object. Okay, now since we haven't we haven't created any constructor without any parameters, so we'll have to pass the parameters. Okay, so let's say the weight is 58 kg. Let's say the height is let's say we take it in the form of centimeters, so 176 centimeters. Okay, and let's say the age is 23. Okay, okay, so we have assigned all the values. Now let's try to print the age of the human. Okay, cout h, okay, to print the age, since we have statically allocated the memory, so h dot, we'll use dot operator. Okay, so age. Okay, now let's try to print this. We must get age as 23. Let's see. Okay, let's clear the terminal first. Okay, let's try to run it again. Yeah, so we are getting 23 as the age. So this is how this keyword works. So let's try for other two as well. S dot weight, the weight should be 58 kg, right? Because we have assigned it in the first at the first place. So let's see. Yeah, so we are getting age as 23 and weight as 58. Similarly with the height as well. Okay, so yeah, let's see. Let's clear the terminal. Let's run this now. Yeah, so we are getting height as 176. Okay, so now let's get back to the screen. So we got to know about this keyword. Now we will work with what are destructors. Now we'll see what are destructors. Okay, so destructors, I told you already about the constructor. So what are constructors? So every a constructor is called when an object is created, so they help in the object creation. Okay, object creation. Okay, now before getting into destructors, we must know one more thing, which is memory allocation. Okay, memory allocation to an object. Okay, memory allocation to an object. Okay, so when we simply create a class, let's say we created a class human. Okay, class human. Okay, okay, and we gave it a public data access modifier, and we written some data member or member function inside this class, and then we simply ended the class. So this class, when we create this, it won't take any memory. Okay, in the physical device. So what happens is, when we create an object of this particular class, let's say we create an object of class human object. Okay, then the memory is assigned to this object. Okay, in that case, so memory is allocated to this object in two ways. So first is the static memory allocation, and the second one is the dynamic memory allocation. Dynamic allocation of the memory. Okay, so in static allocation, how do we allocate the memory in the static allocation? This is an example of static allocation. We simply write the class name, and we simply create the object by giving the object name. Okay, so this is the static allocation. Okay, but how we perform dynamic allocation? So we create a pointer of that particular class. Let's say we create h pointer, and then we put the assignment operator, and then we write new. This new keyword gives the address to the h pointer. Okay, to the pointer of that class. Okay, and then we write the name of the class, new human. And then if the constructor is not a parameterized constructor, we simply end it like this. But if the constructor is parameterized, we'll have to give the values inside this parenthesis. Okay, so since we are not assuming the parameterized constructor, we will create the object this way. So this is an example of dynamic allocation. Dynamic allocation. Okay, now there are two types of memory that are used in static and dynamic allocation. One is the stack memory. Stack memory, you can read about these, and another one is the heap memory. Okay, heap memory. Okay, if you want to learn about this, you can learn in, there are various documentations on these memories. Okay, so in static memory allocation, you simply remember this thing. Okay, so in static allocation, the memory that is assigned to this object is stored in stack memory. Okay, stack memory. And in this allocation, the object is stored in the heap memory. Okay, heap memory. You don't have to go in depth, but if you want to go, you can go. Okay, it is an important topic, and it is often asked what is heap memory and what is stack memory. There are four types of memories, but these two are quite important. Okay, so yeah, this is all about object creation. Let's work. Let's see a program of dynamic allocation. Okay, let's get back to the Visual Studio Code. Let's create the object dynamic in the form of dynamic allocation. Okay, so we'll write the class name. Okay, h equals to new human. Okay, human, and then we'll have to pass the uh, parameters as well. Okay, so to pass the parameters, let's say we give it a, what was the first thing? So first thing was weight. Let's say 58 kg. Okay, 58. Let's say the height is let's say 176, and let's say the age is 13. Okay, so yeah, we haven't created a pointer here, so we'll have to use asterisk. Okay, so now it works. Okay, now it won't give us any error. So let's try to print the age. Okay, so to access the data member when the object is static, dynamically allocated, what we do? Let me take you to the next page. Okay, let's say I created a human object like this, human obj, or let's say the name of the, let's say the name, I kept the name as h. Okay, a new human. I gave it the weight as 58 kg, I gave it height 176, and I gave it age as 23. Okay. So now how do we access the data member? Okay, we had three data member, right? We had age, we had weight, and we had height. Okay, we had height. Okay. In case of static allocation, we use dot operator, right? We use dot operator to access the data members. But here, in case of dynamic memory allocation, we will use arrow operator to access the data member and member functions as well. So let's see how it works. Okay. So if you want to print age, we will print h, then okay, let's write it within the parenthesis h, then arrow operator, and then age. Okay. Yeah. Okay. Yeah. So now let's try to print it. We should get 13 as the age because we have passed 13 in the parameter. So we are getting 13. This is how dynamic allocation works. Okay. Now similarly, if you want to print other two, okay. So let's try to print weight. Okay. Weight. Okay. Okay. And let's try to print height as well. Okay. Okay. Let's see. So upon executing, we get all three. So age is 13, weight is 58, and height is 176 centimeter. So this is how dynamic memory allocation works. Okay. Now I told you that we can also access member functions by dynamic memory allocation. So let's suppose uh, uh, we create a member function. Let's say we create a member function of type void, which won't return anything. Let's say can walk. Sorry, jump. Okay, jump, and let's say we try to print here. I am jumping right now. Okay, right now. Let's say we want to access this. Okay, let's say we want to access this member function now. So what we'll do, we'll simply call this member function. So h, okay, then arrow bracket, then jump. Okay, so yeah, jump. And since it is a function, we'll use parentheses here. And since why the parentheses are empty, because I haven't passed any parameter here. If I would have passed parameter here, I would have also passed parameter in the main function. Okay, so let's comment all of these three statements and let's see what is the output. Yeah, so let's see the output. So I'm jumping right now. That's what I have tried to print within the when the jump function is called, right? So yeah, this is all about dynamic allocation as well. So now let's talk about destructors. Now we know all the prerequisite. So what are destructors? Okay. Okay. So destructors work differently in the case of both the uh, the static allocation, in the case of both the static and the dynamic allocation. They work differently. Okay. And dynamic allocation. Okay. So what happens is that in case of static memory allocation, the purpose of constructor was that it helps in the object creation. So destructor helps in automatically freeing up the memory, okay, that the object has taken or that object has consumed. So once the purpose of object is finished, okay, the memory is automatically freed. So what happens is in the case of static memory allocation, so whether if we have created an object, okay, and static allocation of the memory is done in that case, then what happens is that the memory gets freed automatically and the destructor is called automatically. Okay, but in the case of dynamic memory allocation, the memory has to be freed by using delete keyword. Okay, so suppose we have created an object through dynamic memory allocation. Okay, so we have we created an object of class human, okay, dynamically. So to free up the memory, now at the end of the uh, when the scope, when we don't use the object anymore, when we don't want to use the object anymore, we have to use the delete keyword, delete and then the name of the object. This way you have to free up the memory in the case of dynamic memory allocation, whereas in the case of static memory allocation, the memory gets freed automatically and the destructor is called automatically. Okay, let's see how it works. Okay, so the syntax of destructor. Okay, let's talk about the syntax of destructor. Syntax. Okay, so we'll use this sign, this symbol. Okay, and then we'll write the name of the class of which we have to create the destructor. So we had human class, so human. Okay, then we write empty parenthesis, and then let's say we want to print something to know if this destructor is called or not. Okay, I am destructor. Okay, destructor, so that we get to know whether this destructor is called or not. Okay, let's okay, so let's end this. Okay, so yeah, let's check this thing in the Visual Studio Code itself. Okay, now let's create another program, Destructors. Okay, .cpp. Let's say we write the boilerplate code first. Okay, okay, using namespace standard. Okay, okay, let's say we create a class human. Okay, uh, okay, let's say the access modifier is public. Okay, let's say it has int age, int uh, height, okay, and int weight. Okay, now let's say I create a constructor here. Okay, so constructor, how do we create constructor? We write the name of the class. Okay, simply if you want to pass parameter here, we can pass parameter, but I'm not passing parameter. Okay, I'm just showing you how the destructor works. So cout, I am inside constructor. Okay, okay, okay. Now similarly, if you want to create destructor as well, so what we'll do, we'll use this sign, then human, then the name of the class itself. Okay, and then to know if we are if the destructor is being called or not, we can write a message here. Okay, I am inside destructor. Okay, destructor. Okay, okay. Now let's see, let's try to create an let's try to create an object statically. So let's say we create a human object. Okay, okay, human object h1. Okay, so what we'll get as the output, we'll get that a constructor is being called and then a destructor is also being called. Okay, since nothing is happening after this, right, we are only creating an object. So object created using static allocation, right, allocation. Okay, so let's see what happens. So the first the constructor is being called, a constructor will get called, and then automatically the destructor will get called. Okay, you don't have to use this delete keyword here. Okay, so let's see. Yeah, so first the constructor is called, I am inside constructor, and then the destructor is also called itself. Okay, without using the delete keyword. But what in the case of what happens in the case of dynamic allocation? So let's say we create another object. Okay, using dynamic allocation, so star h2. Okay, we use new keyword in the dynamic allocation which gives the address of the object to this pointer h2. Okay, so new human class name only, and since we haven't passed, we haven't created any constructor, parameterized constructor, we will keep it empty only. Okay, so new object is created. Now let's see what we get as the output. Okay, let's comment this. Okay, let's see what is the output. We will only, this will only call constructor, but the destructor is not called in this case. Okay, let's see if I'm okay. Let's clear this terminal first. Okay, let's see upon executing what we get. So we get only I am inside constructor. So I already told you that when we when we perform dynamic allocation, so this is dynamic allocation, right, dynamic allocation, or the object is being created through dynamic allocation. So in this case we have to call destructor by using delete keyword. So we'll use delete h2. Okay, now the destructor is called. Okay, now you'll see first I am inside constructor and then I am inside destructor. Okay, let's see the output. Yeah, so this is how it works. So we free memory that the object has consumed, this object h2 has consumed using this delete keyword. Okay, so to free memory, consumed by this object. Okay, when we do not need this object anymore, we will use delete keyword to delete, to free up the memory in case of dynamic memory allocation, not in the case of static memory allocation. Okay, so yeah, this is all about destructors, and this is why the destructors are used, okay, in the object oriented programming, to free up the memory. Okay, so yeah, this is all about destructors. Now let's go to next page and let's talk about four pillars of oops. Okay, so I already told you about the two pillars. So first is I told you about the encapsulation. Okay, encapsulation, it means binding the data member and the data function, binding data members and member functions member functions, in the form of packets, you can say, of packets or capsules. Okay, or packets, you can say. Okay, okay, so this is called encapsulation. We use access modifier here to restrict the access or to provide the access of data members. Okay, access modifiers are used in this case, access modifiers for the purpose of data hiding or not. Okay, so now another thing that we talk about is abstraction. Okay, this is called implementation hiding. Okay, implementation hiding. So we hide the implementation uh, of the uh, object, okay, of the member function, okay, which is being called. Let's look at the example. Okay, so let's say there's a class human, and let's say there are two more classes, two child classes to it. Okay, first one is the men and another one is the women. Okay, now let's say these two classes are inheriting from the human class. Okay, I already told you how we inherit. So let's say we create a class men, then we'll do this way. Okay, a colon, okay, and then public, from which class it is inheriting to human class, so human. Similarly, in the case of women also, will inherit like this. Okay, now let's suppose this human class had two member functions. One is uh, eat, we can say, and another one is jump. Okay, okay, let's say human can jump, right? So jump. Okay, so these two, if they inherit the from the human class, they'll also have these member functions, right? So eat and jump, and eat and jump. Okay, so now let's say we created an object dynamically. Okay, so let's say we created a dynamic object of class human class h. Okay, and we called uh, we gave it address of an object of class man. Okay, so new man, like this. Okay, so in this way, we are not giving it the address of a human object, rather we are giving it an address of an object of the base class. So this is what called as abstraction or implementation heading. So let's try to use it. Okay, okay, so let's say uh, let's create another program. Okay, abstraction dot cpp. Okay, so let's say we write the boilerplate code. Okay, 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 so let's say we create the class human. Okay, let's say we create the class human. Let's say we write within the public access modifier, we give it some data members. Let's say age. Okay, and height. We are not going to use them, but let's say we have these data members as well. Okay, okay, so now let's say we define some member functions as well. So eat. Okay, void eat. Okay, let's write some message as well. I am eating right now. Okay, right now. Okay, okay, and let's say another is jump. Okay, so let's say, let's write the message. Okay, I can jump up to 6 feet. Okay, let's say this is the message. Okay, now let's say, I create an object. Okay, sorry, I create another class, another classes. Okay, let's say I create a class man. Okay, which is going to inherit from this uh, class. Okay, from the class human. Okay, human. Okay, uh, so let's give it access modifier as public. Okay, now okay, and let's create another class. Okay, class women. Okay, having uh, inheriting from the same class human only. Okay, 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 okay. So I'm not defining anything inside these class. So these class will already have these eat and jump as the member functions. Okay, let's see. So when we create an object dynamically now, so let's say we create a human object. Okay, to create the human object, we'll write human star object. Since we are creating the object dynamically. Okay, is equals to new. Let's say now we give it address of an object man. Okay, new man, like this. So in this is what called as abstraction. Okay, we are hiding the implementation. Okay, now let's say we try to print the a, any of one property h1. uh, we try to jump, we call the jump function now. Okay, let's say, okay, we won't use this thing, right, since it is already a function and it is a function of type void. uh, what is wrong with this? So I think I'm doing something wrong. Yeah. So H1, it should be capital G, right? Okay. So now upon calling this, what happens? Okay. So let's say in main class, I overload the function. Overload the function means, let's talk about it. Okay. So function overloading means, let's say, let's move in the next bit. Let's move. So human had two member functions, right? It was having eat and jump as the member function. Okay, when I inherit from this human class. Okay, let's say it has two other child class. Okay, which are inheriting from the human class, men and women. So they will also have access to these data members, right? They will also have access to these data members. But now what if I define one more uh, init function inside this men class, and I give it a different message. Okay, see out, I am eating and I am a man. So if I try to print eat function now, then this eat function is going to get called, not the eat function in the human class. Okay, so yeah, this was function overloading. Okay, we do the function overloading in two ways. Okay, function overloading in two ways. One is either by changing the data type of the parameters. Okay, another one is by uh, the number of changing the number of parameters. Let's say in this jump function we pass two parameters in the human class. So here if we want to overload the function, we'll pass three parameters as per this second type of function overloading. And in the first, from the, how do we overload the function? By changing the data type. Let's suppose in jump function I passed a parameter int value. Okay, now in the jump function that I have implemented within the main class, I'll pass the parameter as string value. this might be some different value and this might be some different value. So this is how we do function overloading, by changing the data type. Okay, now let's get back. Okay, now let's try to define a function. Okay, eat function defined. Okay, eat function within the main class. Okay, so void eat. Okay, now let's say I write I am eating. Okay, and I am a man. Okay, let's say I write this message inside this. Now let's see what we get upon calling this function. Okay, so yeah, so we are getting I can jump up to 6 feet. So uh, this function is getting called. This function is getting called. Okay, now uh, what is function overloading? Okay, so let's say I create object of class man. Okay, man. Okay, star m1. Okay, equals to new man. Okay, man. Yeah, now let's say I try to call this jump function again, sorry, eat function. Okay, because that's what I have overloaded. So this eat function is going to get called and not the one that I have. Okay, 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 okay. So okay, okay, let what just happened. Okay, yeah, now it is fine. So instead of, okay, is it fine now? What is wrong actually? Okay, yeah, so now it is fine. So now instead of, this eat function inside the main class will get called, and not this eat function I'm eating right now. This won't get called. Rather, I'm eating and I'm a man. This message is going to get printed. When we call jump eat function for the man object. Okay, let's see if it works or not. Okay, yeah, so I am eating and I am a man. Okay, now if what if we do not have this implementation? Okay, then the eat function of the human class is only get called will only get called. Okay, so I am eating right now will get printed on the screen. Okay, let's see. Let's clear the terminal. Yeah, so I'm eating right now gets printed now. So yeah, this was all about abstraction. Now the third thing that we are going to talk about, okay, is polymorphism. Polymorphism. Okay, poly means many, and forms, morphism means forms. Okay, so polymorphism means, what it implies is existence, okay, of a particular entity in many forms or various forms. Okay, many forms or various forms. Okay, so let me tell you how. So the function overloading that we talked about, function overloading, okay, is an example of polymorphism only. Okay, so function overloading, then we also talk about operator overloading. Okay, sorry, so we also talk about operator overloading. Okay, operator overloading. Okay, overloading. So these two are the examples of polymorphism. Okay, so uh, we also call these two as, there are two types of polymorphism. First one is compile time polymorphism. Okay, this is the first type. Under this comes function and operator overloading. And second one is the runtime polymorphism. Okay, runtime polymorphism. We are going to uh, talk about the compile time polymorphism only, because this is the most commonly used. And you have to, like, if you want to understand what is runtime polymorphism, you can look for some documentations on the internet. Okay, it is very, quite simple to understand. But since we are going to talk about only the function and operator overloading here, so yeah, so function overloading, I have already told you that, to override a function, already existing function, by changing the data type, and by changing the either changing the data type from, like, let's say earlier we had int, now we change it to string or some character, whatever as the parameter, and by changing the number of parameters that we have passed. Okay, by changing the number of parameters passed in the passed to the function. Okay, now the another example that we are going to see is operator overloading. Okay, so what we do by, we already talked about the class, right? What is the purpose of class? So let's see. So class is used to create user defined defined data type. Okay, now uh, so if we create user defined data, let's say we want to create a data type of complex number which would store the complex number we already know that are written in the form of a plus ib, right? So when we create a complex class complex number, and when we try to create this data type, okay, so what will happen is that when we create object of this class, let's say I name it complex. Okay, so complex c1, and I give it the value of a and value of b, and then I create another class complex c2, I give it a and b as well. Okay, now if I write c1 plus c2, okay, so our machine do not know how to add these things. Okay, like how to add these two complex numbers, since they are having a plus ib and a plus ib as the values, right? So our machine do not know how to add add these two values. Okay, so we'll have to overload the operator in this case, like we'll have to define a meaning to this plus operator. So this is what called as operator overloading. Okay, we'll have to change the definition. So what we'll do, we'll create the operator this way. Okay, so what is the syntax of the operator? Okay, so syntax of the operator is like this. Okay, first we write the return type. Okay, return type would be complex in this case since the class is complex. Okay, then we will give the operator. Okay, we'll write operator here, then we'll give the operator sign. Okay, what sign the operator has? Let's say we want to overload this plus operator. Okay, so plus, and then we'll give the other object, then we'll pass the address of the other object. So complex and c2. Okay, this way. Now inside this we'll create another complex, okay, answer, because that's what we have to return, right? So now we already know about this object. This is the pointer to the current object, right? This keyword is the pointer to the current object. So to denote the a and b values of c1, what we'll do, this dash c1. Okay, this that to sorry, not c1, actually c1 is the object, right? c1 is not the data member. So this, then arrow operator, then a. Okay, so this arrow operator a will denote the a of this c1. Okay, a plus ib, so it will denote this a. Okay, for c1. Okay, if you want to add like the value of let's say it is a1 plus ib1, right? So we want to add a1 into a, so what we'll do, we can simply write it this way. Okay, so we want to add into, like, let's say we have created the answer object, right? So what we'll do is, let me erase this. Okay, so I already told you that this dash a, this arrow operator a represents the a for value of a for this c1 object. Okay, and this c2 object we have already passed the address, so we can simply give it c2 dot a. Okay, whatever. Okay, we can use dot operator in this case. So answer. Okay, answer dash age, sorry, not age, actually, answer a, since this complex also will have a and a plus ib, right? The value stored in the form of a plus ib. So a of this complex. Okay, since we have created the object as answer, so answer, then arrow operator a is going to have this arrow operator a. This arrow operator a represents the current object. So current, the value of a of the current object, this c1 object. Okay, plus, okay, Okay, let me take you to another page. Okay, let's write the constructor again. So it will have the type complex. Okay, then it will have operator, then the operator which we are trying to overload, let's say plus. Okay, then hero, and c2 is passed as the parameter. Okay, the address of c2 is passed as the parameter. Okay, now we create another complex object to store the values of addition of both the objects, right? So this is complex. We have two objects, complex c1 and complex c2. Complex c2. Okay, let's say this, the value of a c1 is a1 plus I b1, and let's say the value of c2 is a2 plus I b2. Now we want to add these two complex number. So let's say we want to define the plus operator as a1 value gets added to a2 and b1 value gets added to b2. Okay, so how do we do this? So complex answer we will create. Okay, so this will have uh, a plus ib, value stored in the form of a plus ib. We want a to be equal to a1 plus a2. Okay, we want a equals to a1 plus a2. We want to store the answer into this. Okay, so and we want b is equals to, okay, let me scroll this up. Okay, b is equals to b1 plus b2. Okay, we want it this way. Okay, so what, how we'll do that? We have, let's erase this. Okay, yeah, so now what we'll do is that answer a, okay, a of answer will be equal to this dash, this arrow operator a, which represents a1. Okay, the pointer to current object c1. Okay, plus uh, c2 dot a. Okay, so this represents the pointer to the another object that we have created. Answer b is going to have this arrow operator a, sorry, b, in this case b, right? B. So this dash, this arrow operator b represents the value of b for c1 plus c2 dot b. Okay, and finally we will return it, since this is the return type, right? So we will return answer. We are returning the same object. Okay, answer. Sorry, return answer. Okay, answer. Yeah. So this is how it should work. Okay. Now let's see how the operator overloading works. Okay. So let's create another program. Okay, so yeah, let's write the boilerplate code. Okay, okay, let's create the class complex. Okay, complex. Okay, okay, let's say we have two values b. Okay, now these are the two data members. Now let's say we want to overload the operator. Okay, to overload the operator, what we'll do is we'll define the operators our way. Okay, so we'll write the return type complex. Okay, then we'll write operator, since it is operator overloading. Then we want to overload plus operator. Okay, now let's say inside this we pass okay, we pass the address of the second another this is how we create, like this is how we give it the value, right? So we'll pass the address here. We'll pass the address of another operator. Let's say we call it b here right now. Okay, so what we'll do, or let's say we call it c2, right? We had the another operator as c2. So yeah, okay, so let's say we create another object, complex object. Okay, let's say answer. Okay, so answer a is going to store this dash uh, current object, the pointer to the current object, which is going to be plus. Okay, plus we'll have another value as c2 dot a. Okay, so this is how we are going to represent the sum. Okay, uh, here instead of arrow operator, I guess we are going to use dot operator. Yeah, so answer dot b is going to store this dash b, which is the correct pointer to the current object, and then c2 is which we have passed, the address of which we have passed in the parameter, right? Dot b. Okay, so yeah, this is how it works. And lastly, we have to return this answer. Okay, answer object. Okay, now let's try to create two complex numbers, and then let's try to add them. Okay, so complex c1. Okay, then let's say complex c2. Okay, c2. Okay, now let's assign the value. C1 dot a is equals to 5. Okay, c1 dot b is equals to, let's say, 3. Okay, let's say 8. Okay, let's say c2 dot a is equals to minus 1, minus 3, and c2 dot b is going to be, let's say, 1. Okay, okay, uh, 2, let's say. Okay, let's now try to add. Okay, so we'll have to create another object only. So c. Okay, let's call it c. We'll add c1 plus c2 here. Okay, c1 plus c2. Okay, we already, since we have already defined the definition of this plus now. Okay, using this operator overloading, now they get added according to the definition. Okay, now let's try to print the values of a and b in the c. Okay, c out c dot a. Okay, and c out c dot b. Okay, let's use endl operators as endl as well. Okay, yeah, so let's try to execute this and let's see what is the output. So it gives us error. Okay, so let's see what is the error. In the main function it says error expected at the end of the input. Okay, so c1.b, after we do this, what is the error? I'm not able to debug it right now. Let's see what we are. Yeah, so we got the output. It was just a bug. So the output is 2 and 10. Let's add the values. So 5 plus minus 3 gives us 2, whereas 8 plus 2 gives us 10. So the output is same. Okay, so yeah, this is how we perform the operator overloading. So this was all about the fundamentals of object oriented programming. And yeah, so let's so here the course ends, and I hope you'd like the course, and the things that I've taught in this course are extremely helpful in understanding C++ and the object-oriented programming in C++. Now, from here on, you can start, doing, trying to learn multiple things through documentations. Okay, so what I recommend is that you must uh, read documentations. Okay, rather than viewing lectures on YouTube, right? Read documentations. Okay, read documentations. So from documentation, what I want to say is, like, you can read GFG documentations that are present online, right? They'll give you a lot of idea, a better understanding of all these things. Like operator overloading, you can search on the GFG and you will find a documentation over there. So you can read that documentation after this lecture, and you'll get to know what I'm talking about. Okay, so it is all of these things are important. Like, there are many documentations. Okay, W3 schools is also there. Okay, you can read their documentations as well. So yeah, this was the end of this course. I hope you'd like the course. So that's it for this course.